Hello and welcome to this tutorial on how to create traps in your game in Crayta. So in this tutorial we're going to be looking at giving your players the opportunity to lay traps around the level for other players to run into. I don't know about you, but I love it in games where I can basically lay traps and then avoid any confrontation in the game itself. And we can just watch other people run into the traps. You don't have to make them into traps or be nasty to each other. You can turn them into presents that you lay around the level. And then when a player finds them, it showers them in fairy dust, which is an alternative thing you can do with this. So whilst I'm calling it traps, the logic itself you can actually apply to lots of different situations. So let's get started. How are we going to do this? Let's break it down a little bit. So we have an inventory system, and I'm going to start with a game that already has guns and inventory systems set up. If you're not sure how to do that, there is a tutorial for that already. And then so what we need to do is make it so that a player can hold on to a trap without it exploding. And then position it in the world somewhere, and then another player that might run into it or whatever trap logic there is sets the trap off, at which point the trap is destroyed. So there's a few pieces of logic, but it's nothing too challenging. It's stuff that we've touched on before, the inventory system stuff we've looked at before, the vector maths involved in any trap logic that might come up. We've kind of had a little dabble in that. And the way we created the grenades tutorial as well, that will come in handy too. So first of all, let's look at the game. So I have a player and they have an inventory, and they have, at the moment, just a gun, but we can make it so they've got traps too. So the way to create something that will go in the inventory, first of all, we need to create a template. And we're going to do that by grabbing the mesh that we want to represent our trap, which is a landmine, and turning that into a template. So it's going to be called trap_landmine, particularly useful name there. So I now have a template, which means I can delete it from my game world, and I can go and edit the template up here, trap landmine. So there's a couple of scripts that we need to add to something in order for us to be able to hold it in our inventory, which is the first problem that we're trying to solve here. So let's add those scripts. If you've installed the gun package or the inventory package, you should already be able to find these scripts here. So the first one we need is pick up spawner script. This will allow us to pick up or have this particular item in our inventory. And I'm just going to set the spawn time to 5 seconds each. The pickup sound, I want that to be the grenade pull pin sound. It's quite a good sound for this. Use on collision, we don't want checked, because when you run into this, it's going to explode. So you don't want to explode and pick it up at the same time. Use self as template, check. Enable collision on children, check. Show on init, check. Show on init instantly. That's all good. So that's the first script, is the pickup spawner script. The other script that we need here is the inventory item spec script. And what that does is it specifies and describes how this is going to look in your inventory. So this has got nothing to do with the trap itself, and it's just what does it display like, so that users can see it and know that they've got it selected. So we need a friendly name. We can have multiple, so let's put can stack. Let's set the grip type to pistol, because why not? And let's also put the icon asset on there. We can check this works immediately by going over to our user and adding a new inventory default script to the defaults folder. And in here, we're just going to add our trap, as we're going to say, let's have 10 of those. And so when I start the game, I should have another thing in my inventory, which is this. Now, at the moment, it doesn't do anything. If I try clicking, it's not going to do anything. So we need to solve that next problem. So the next problem we're looking at is going to be, now that we've got it in our hands, how do we put it on the floor? So this is similar to what we did with the grenades, but it's going to be slightly different, and we're going to use some slightly different coding for it, because there's actually some better ways to do it. So let's go over to our trap landmine, and let's create a script which is going to manage like positioning traps in our level. So this is going to be attached to the landmine, and it's going to be a new script. It's going to be called trap script. I'm calling it trap script, which is quite abstract because I want to be able to use it for all of the traps that I make in the level. I don't want to have to recode the same kind of logic but slightly differently each time. I need to make it abstract enough that I can reuse it easily, but specific enough that it's doing the job I want it to do, and I'm not making a game engine out of it. Specific so that I'm not coding forever, but abstract enough so that I don't have to recode the same thing but slightly different each time. So here's my trap script, and something that's quite good to do if you're just embarking on a new script and some new functionality is giving yourself a little bit of some notes to follow. So I know, for example, that I'm going to need to do an onPressed function. So when a user presses a button, while they're holding it, check that this is being held by a user. These are just notes for myself. Check that this is being held by a user. What else do we need? We're going to need to position, create a new landmine in the world, and position the landmine in the world. And at some point, we're going to need to remove one from the inventory. So when we had 10, once I place a landmine in the world, I need to remove one. So some logic there that we're going to need. So where we've got an onPress function, and this is going to be first check that this is being held by a user. Then it's going to probably needs to remove one from the inventory, then create a new one, position it correctly, and activate it. I don't know if it needs to do that, but it might need to do that if it's a different kind of trap. So the landmine might already have that functionality. Okay, so we've got some basic stuff here. Check this is being held by a user. We also need to check which button was pressed. So let's write this now that we have this stuff. So we know we can do onPressed function. So we can get that from the API. There's an API hook, which basically means something that's called from the game engine itself, from Crayta itself, called onButtonPressed, which means that Crayta, when a user presses a button, Crayta will call onButtonPressed in this script for us, and it will send through a string which is going to be button name. We need to check which button was pressed. That's our first bit. So if button name is primary, there's two, there's multiple. I'm going to check that it was the primary button that was pressed. Then, and because we've got an if, then let's have an end. So we've got that tick. And then we can decorate this. We can do that or not. We can do that at the end for the things that we've checked off. Check that this is being held by a user. Okay, tricky thing. How do we know whether this particular entity is being held? Well, we are going to need to know that. So here is where something comes in quite handy. Let's go to the player and the player inventory view and look at the inventory view script. And in here, you will notice on line 33, there's this really, really helpful thing here. So when we switch to a new item in our inventory, this function here runs, and this then sends the onHeld event to every script that is attached to whatever it is we're now holding. So if we've got a trap with this trap script attached, at some point an onHeld function will try to be called on this trap script when the user has switched to a trap. And we can leverage that. We can use that in order to get hold of a few things. Well, in order to know whether this is being held by a user or not. So let's get it. So onHeld. So we can look at that. It's the exact wording there, onHeld. there. And then in the arguments, it's sending us the player, self-get entity. This is attached to the player. So getting the player and then sending that. And it's sending some data as well. I don't know what this data is, but I do know that the player will be coming in handy. So let's get hold of that. We're going to need that at some point, surely. So this function will be called when we switch to this entity in the inventory. So trap is being held. We can check that by using a print statement, which will output to the console when we switch to this, and just check that that's going to run. And we could also do another print here, which is just going to lay the landmine. It's not actually going to lay the landmine, but it's telling us that that's the logic that will run when we press the primary button. Let's check that that all works. So going to the landmine, trap is being held. Great. Pressing the primary button, lay the landmine. Great. Okay, so we have some basic logic in our trap script. And so we know this is being called and we know this is being called. So we can carry on with our checklist. Check that this is being held by a user. Well, now we have this script, this function here, we can actually store our player. So self.player is, in the initialization, we'll create a variable called self.player. And it's a variable attached to this script, so self.player. And then in the onHeld function, we can store the player. Self.player equals player. We're now putting the player that's been sent from the inventory view script from this function. It's being sent here to the onHeld, and it's being sent the player. We're getting that player, we're putting it in the self.player variable. So that's useful because now we can do if button name is primary and self.player is not equal to nil. So this is two things now. This is an if statement that says if they press the primary button and the player variable is not equal to nil. So for the player variable to not be nil, we know that this function must have run, and we know that we are currently holding on to this. Cool. Lay the landmine. And self.player not equal to nil, then lay the landmine. Blah, blah, blah. Okay, check this is being held by the user. I think that's done. Now let's try it. So switching to this. Yes, lay the landmine. Still works. Okay. Check, check. Remove one from the inventory. Okay, next problem. How do we remove a landmine from the inventory? Where we're going to place it down. So this functionality exists in the user. So the user keeps count of all of the things that you have in your inventory and all of that sort of stuff. So in the user in the inventory script. So let's open the inventory script and find whether there's any way that we can remove an item. Oh, look at that. Line 159. We can do remove template. And then we send through a template and then how many of those things we want to remove. Brilliant, we can do that. So we need to call this function. Now, you could do this in a tightly coupled way where you specifically reference that the player and all of that sort of stuff. Or you could specifically reference this inventory script, or we can just send an event to the player and get the inventory script to manage the rest of it itself. Okay, so the way we're going to do that is we're going to do self.player, and then we're going to get hold of the user. Okay, because this inventory script is attached to the user, remember. So we can get hold of the user just by using the player and running the getUser function. Then we need to send to scripts. So this is the same sort of thing that happens here, where it says send to scripts and it sends the onHeld function, which we used here. Here we're going to use send to scripts, but we're going to call this function ourselves. Remove template is the name. So we can do remove template here. So we're calling that on every script on the user. The arguments that we need to send are a template and the amount of things we want to remove. We can get hold of the template in this particular thing. So self get entity get template. And how many do we want to remove? 1. There we go. So that should now decrease. Actually, I'll keep that in there. That was quite handy. That should now decrease the number of landmines when I press the button. So going to my landmines, press the button. 9, 8, 7, 6, 5, 4, 3, 2, 1. None. And look, when you reach none, he automatically drops it. Brilliant. Okay. So that is that script started. And now we can carry on to do the next bit. So let's go back to our trap script. So we've got remove 1 from the inventory. Check. Done. Create a new landmine in the world. Okay, so we can do that. That is similar to what we did with the grenade stuff. So that's in that tutorial. But if you don't know, you can basically get hold of the world by doing get world, which is a global function, and then spawn. So here it says, look, the world calls the function spawn, and then we need to send through a template, a position, and a rotation. So it needs what you want to spawn, where you want to spawn it, and what direction you need it to face in. So the template is the same as this thing here, get template. So when we're using this function twice, this function twice, we really should now grab that once and then store it somewhere. So let's do that. So create a local variable called template, which stores that template. Use that there and use that there. This then reduces the number of calls that we need to make. So every time we use these function parentheses and we're calling a function, it's got to go and do that. It's got to go and get hold of the entity and then come back. And then it's got to go and get the template from that entity and then come back. And that takes time and that uses memory, whereas we could just do it once, store it in a local variable, which will only exist until it reaches the end, the next end statement. Store it in a local variable and reuse it again and again. So spawn the template. The position needs to be the position of this current template. So self, or does it? No, it doesn't. We need to get hold of the position we want to spawn it. Okay, because we need to spawn it where in the world we want to position it. So another bit of logic here. How do we know where we want to position it? Well, when I'm playing a game and I want to lay a trap, I'll probably look where I want to place it and then press a button to place it there. So I can actually get hold of wherever I'm looking. There's a function for that. In traps, in here, we can actually do self.player get camera look at. No, we need get look at position. And that returns a vector. So let's store that. And that's where we want to spawn the template. So look at pos. So that's where our character's looking at. So if they're looking at the floor or they're looking at a wall or wherever they're looking, it will spawn the landmine there. And the rotation, we can just set that to 0. Rotation.0. So now in our game, let's check that that works. So we switch to our landmine, look around, and we can position landmines everywhere. Brilliant. Okay. Okay. Great. Now, I think it's a little bit unfair to be able to place a landmine, you know, there. So I might, yeah, I'm going to make it so that there's a reach, a distance that I can do this. And I don't necessarily want that the same for all the traps. I want it to be shorter for some and longer for some other ones. So let's make it into a property. And we're going to call this player reach so that we know it's to do with the player. And it's a number. It's just going to be the distance that we can reach from ourselves. The default, so I don't have to set it every time, is going to be 400. So let's use that to make sure we're not positioning it too far away. So get the lookout position. We also need the player position. And we're going to test how far away the player is from where they're looking before we spawn a new landmine. So we can do that quite simply. Lookout to player vector equals lookout pos minus player position. So we're getting hold of the vector between these 2 points, and then we can do if lookout to player vector length is less than self.properties.playerReach, then so check that the length, the distance from us to where we want to place the landmine is less than whatever value we want to set it to, and then if it is less than that, then go and spawn the landmine. And we can actually go to the landmine and set, yep, it's set up already. So now when I switch to landmines, I shouldn't be able to place them over there, although it's still decreasing. So my logic is slightly out of order. That center script remove template part needs to go here. Let's just organize this so that we've got some descriptions about what things are doing. That might have helped me avoid that error. So we've got those two there. Remove one from the inventory goes here. Create a new landmine, position the landmine goes here. There we go. Activate the landmine. Let's think about the next step. So the next step is going to be, and I don't need that anymore, and I don't need that anymore. This needs to come down here, and that's done. And then this needs to be positioned here. So to do, we need to figure out whether we need to do that or not. So, so we have a onPress function, and it's basically checking how far away we're looking, whether we press the right button, and whether we have a player already set. And if we've got those things, then it's creating a new landmine where the player is currently looking and removing one from their inventory, which is kind of what we want to happen. Now we need to do the trap part of the trap. So that's actually quite straightforward. We're going to use the OBI components, which is a package that's already made. It's made by Adam O at Crayta at Unit 2 Games. So the guys that made Crayta made the OBI components package, and it comes with some really good templates for obstacles that you might want to use. And it also comes with the scripts that those obstacles used, and that's what we're going to leverage here. So I've already got quite a few scripts going on, but I need some more scripts. I'm going to add a new script to my landmine trap, and this is going to be activation timer script down here. And I want that set to 0 and the deactivation set to 0.5. And what this does is this will fire the event in the next script I'm going to add, which is the obstacle blast script. And this manages all the explosions and stuff. So this will make an explosion happen, it will make the sound happen, it will damage the player, it will do all the things it needs to do. So the blast sound we're going to use is explosion medium. Yeah. The blast effect we're going to use is explosion medium. Blast strength, blast radius, damage player, yep. And we want to damage them 500. And that's all you'll get by default. I've actually added another thing, which I will talk about now, which is this single use properties. So I've added a new property to this script. And what this property is all about is if this is a single use item, i.e. not something that just explodes whenever you walk into it, like a landmine will explode once and then the landmine will be gone forever. So that's what this single use does. And it basically says, if this is a single use item, i.e. you want it to be gone from forever when it explodes, then set the visibility of the landmine to false, and then schedule a function to destroy the landmine. We're going to schedule this function here because otherwise it will destroy all of the sounds and explosions and stuff that is going on, when this explodes. So yeah, we're going to schedule the destroy to happen after about a second. But the landmine itself won't be visible for that. It will just be happening in the background. It'll be essentially just cleaning up in the background. So we've added the obstacle blast script and we've added the activation timer script. Now all we need to do is say on collision of our landmine, so we're up in the mesh here, on collision we need to go to the landmine and we need to run the activation timer script, and the go function needs to happen. And that will then explode when we collide with it. So I'm holding my landmine. I put the landmine there. And no such luck. So the reason that that's broken is, if I go to the landmine, let's just check. We might need to activate the landmine for it to work. But let's just position one in our scene and see whether it explodes when we walk into it anyway. So let's get our trap landmine, do some debugging. So the reason that wasn't working, if I go to the trap landmine, I need to, in the activation timer script, I need to set up the obstacle blast to work. So when it activates, I want the obstacle blast to blast. And when it deactivates, I want the obstacle blast script here to reset. And now that I've done that, I should find that I can walk on this and it explodes. And if I change to my landmines, I can position some of those and the same thing. So now I have landmines working. Hey, you could create a game where you lay a landmine and you have to use it to jump onto the roof of a building. Okay, now you might have noticed they weren't being destroyed. I'm just going to check that I've got single use checked. Nope. So if I check single use, I described how this code works before, and then you should see that they explode. So let's remove that landmine from the game world. And that's essentially how to get landmines working in your game. So if I had the health installed, then I would be damaging my health as well. Now that we've talked about landmines, let's have a think about how to do a different trap. So the next trap I'm going to look at is some kind of proximity sensor, sort of like a landmine, but let's do it so that it's almost like a tripwire. Now, how would we do that? So the script itself is going to be relatively similar to the landmine. It's going to be essentially, but rather than being on collision, this script needs to manage its own trap, almost like trap logic. It needs to raycast, so cast a line and see if something crosses that line, and if that something is a player, then it needs to explode. Or in fact, it doesn't need to be a player. If something crosses that line, then it will explode. So let's have a think about that. So we go to the templates, and what I'm going to do is I'm going to actually duplicate my trap landmine, and I'm going to call this trap, and this is going to be tripwire here. Let's go and edit the trap tripwire. So the mesh itself is not going to be a landmine. change this. It's going to be, let's change that mesh asset to, I think it's called security laser. Yeah, security laser beam. And we don't want it to explode when we walk into it because we're going to explode it using something different. So this is tripwire. Let's also just test that this works. So we've got some landmines, we've got some guns. Let's add some more things. Inventory default script, and this is going to be tripwire. And let's get 10 of those. Oh, I need to update the inventory item spec script because it looks exactly the same as the landmine. So let's do that. That's down here. So this is going to be tripwire. And the icon asset is going to be in meshes, and it's going to be the security laser. No, let's use the laser beam. We don't have to use the same thing. Let's just use the laser beam there. So now we've got a few different things. And actually I can position this and all of the position logic is already there. Cool. Okay, so the laser beam is going to be slightly different in a couple of ways. So the first way is the rotation 0 here. That's going to be an issue for our security laser because we need to be able to position it so that it faces in different directions. So let's just mark these as done, but also add rotate the trap, and this should be trap here now, to the right, face the right direction. So we need to do that, and we also need to handle the trap logic. But first, let's get it positioning correctly. So the way we're going to do this is we need to use the direction we're facing to get hold of, we want it to approximately be looking back at us, but we want it to clamp to one of the 90 degrees. So either north, south, east or west. We want it to clamp to one of those compass points because our game is based on voxels, and it would be a good idea for it to match up. So for example, if I wanted to put some lasers down this corridor, I'm going to want it to be able to snap to facing the other way. So let's do some maths. So in here we need to rotate it. So the first thing we need to do, we already have got the vector we need, which is look at to player vector. So the position we're looking at, which is where we're going to spawn our laser, to where we are. And we can use that because that means that it will be the same sort of direction each time, so that it's possible for a player to kind of plan which direction it's going to face in according to which direction they're facing. So let me just refer to my script here. So we need to get hold of the trap rotation. So to do that, we'll create a variable called trap rotation, and this will be based on from vector. We can use from vector, which takes a vector and turns it into a rotation, and the vector we need is the look at to player vector. Then before we go any further, let's just set a couple of aspects of this to 0. So we need to set the pitch to 0, and we need to set the roll to 0. We want it to be flat. Trap rotation dot yaw, which is the other one. So, oh, are we using that? No, we're not using that yet. Let's put it in there. Let's see whether this works. Trap rotation. Okay, so it always faces us, which is possibly dangerous, but that's great because it means that we can really easily, like, if I wanted to go to that corridor, and place some lasers down here. That's great. I can do that. But I don't want them to look at me specifically. I want them to snap to one of those contrast points that I was talking about. So the way we can do that is let's store the yaw in this, in a variable, and then we just need to multiply that. We just need to, let's just do it once here. We need to divide it by 90 because that will then give us a number between, well, if it's 0 to 360 degrees, dividing by 90 will give us a number between 0 and 4. But if we want to clamp between that, then we can do math.floor, which will round down. Now it would be better if we could round, but Lua doesn't have a rounding function. So we will round down, but we will add 45 degrees so that it will round up if it needs to. Hopefully that makes sense. So we're doing increment it so that because it will always round down, and then divide it by 90, which will give us a number between 0 and 4. Then we're doing math.floor of that, which will round it down to either 0, 1, 2, or 3. And then we're going to multiply that by 90. And that will give us the correct trap rotation Y. So that should lock it to one of the 90 degrees. Let's find out. Okay, that looks okay. That looks okay too. Hey, there you go. So that's locked it to one of the 90 degrees. Let's check down our corridor, faithful corridor. Great. Okay, so now that we've got that position correct, we've got the rotation accurate, we need to think about how we're going to trigger these. And that's going to be a separate script, I think, because we don't want that script on our landmine. We want it just on our tripwire. So let's add a tripwire. Let's just call it tripwire script. Tripwire. That's a different thing altogether. Tripwire script. Let's go into our tripwire. This is going to need an update function. So on tick, which is called every frame. And every frame we need to say if we, let's write this out. If active. So we need an active because otherwise when you're holding it, you're going to be possibly exploding all the time. So if it's active, raycast, which is directly sending a laser out into the world to check if there's something in front of this. If there is, and it's a player, explode. And that will be an event. So we should do that bit first, maybe. So name is raycast crossed. Type is an event. And then we're going to do, we need our active. Self.active is false by default. If active, so if self.active, then. So the raycast will do last. Yeah. And this function actually is a callback in the raycast. So we can do that there. Let's just see. Yep, so raycast crossed. This is going to be the go on the activation script, which then calls the blast script. Okay. Which was originally called by, you know, on the landmine, it's called by on collision, but now we're writing our own trap logic and we're saying that. So now let's do the raycast. So that's get world and then raycast. We need a vector start, a vector end, an entity to ignore, which will be us, and a callback. So the vector start will be our position. Like that. The end will be our position plus the direction we're facing multiplied by the length of the beam. So our position. Here we go again. So we're using two things here. So we're actually using multiple, we're calling this multiple times, and we don't need to do that. It's better if we don't. It's more optimized. So do get hold of the position and store it in a variable called pos. And we can do pos plus, this is going to be the direction we're facing. I think it's get forward multiplied by the length of our ray. That's not how you spell type. Let's put that first. Get world, that. And then we need an entity to ignore, which is ourself. We don't have to have an entity to ignore. It's just a good idea to do that. I'm going to just do some formatting so it's easier to read. 1, 2, 3, func 3 arguments. Fourth argument is our callback. That, and then I'm going to put that there. So our callback gives us two things. It gives us the thing we hit and some collision information about the thing we hit. I'm just going to check which way round they go. It is that way round. He got it right. Yay. Okay, so here at this point, because we've done loads of programming without checking any of it, let's do a raycast hit. Let's do some print statements. Let's do that there and see whether that works. This needs to be ray start. That's fine. Just checking this. Okay, so this might have an issue, but let's test it and just see whether it works. Okay, so it's having a problem on the floor. Okay, so a couple of things. Have I set a ray length? No. This is why it's a good idea to use default things, so that you don't forget. Let's just set the ray length to 500 for now. So let's try that now. It doesn't work on the front. Okay, still not quite right. Raycast crossed, not being called yet. So this is the function we're running. It's active. It's not active. So we need to actually set this to active. So now we're going back to this trap script. And remember I did that to do. We didn't need to activate the landmine after all. But we do need to activate the trap. So how do we do that? Well, we've kind of done something here similar where we've done a center script. So it might be a good idea because we don't know whether we're going to need like loads of script attached to this trap or none. And we want to keep it really like open to having more scripts or less scripts. Let's get the entity and let's center scripts. Activate trap. Let's just do that. And then in Tripwire, activate trap. And here we're just going to do self.active equals true. So tripwire, put E there. Okay, so raycast hit. Raycast hit constantly. Okay, let's do a quick check in my tripwire and see whether we hit what we hit. So we know this is working now, and we know that the raycast is working. So let's see what we hit. If it's a character, then let's only output that we've hit it if we're a character. If a character hit it. Interesting. If hit entity is a character. Okay, so maybe it's. So the issue that I was facing here is not in this tripwire script, but what I can do in here is if I get hold of the entity and trace out what its name is, that will give me some indication whether the if statement is working correctly. So now I'll place a tripwire in my game, and you can see it's tracing out my player constantly, regardless of whether I'm crossing that ray or not. So it's actually, the problem is in here, and it's where I'm activating what I'm activating, which trap. So on button pressed, as long as I've got the player and what I'm actually activating is the one I'm holding. So I'm activating the trap that I'm holding, which is not ideal and not a good idea. What I need to activate is the trap on this one that was spawned here. So we're going to do local. We're going to store what was spawned there. New trap equals. And then here we can just do new trap, center script, activate trap. So now when I place this trap, I get an error, which is better than before. And the error I'm getting here, it says attempt to index local hit entity a nil value, is because it's not hit something. So we need to check if hit entity is not equal to nil first, then we do that. So it will try this first, and then it will try this, which should stop that error coming up. Okay, so it's not hitting at all now. The reason for that is that the ray is coming out from behind. So we just need to do minus. So we're effectively going backwards. But that's because of the direction that the laser camera is facing. So we're going to go backwards, and we're also going to add essentially like the length of the camera so that we're not hitting the camera by accident. So we're going to be going for this. We're going to be getting hold of this forward again. So let's grab that, store it in a variable. So we're going to do that times that plus that again, the ray direction again, times something like 100, which is going to be an arbitrary value to start. There we go. So that it doesn't accidentally hit itself, essentially. So now that we have that, let's just check our corridor. So when I walk down here, I should be getting lots. Yeah, okay, so we're getting some hits. Not as many as I wanted. So it's working on there. It might be burying a little bit too much in the walls. I wonder if the ray is too buried in the walls. That just means we might need to, rather than adding it here, let's add it to the position that we start the ray. Let's call this something more descriptive than pos. So we got ray start plus ray direction times the length of the ray. And we're now just moving ray direction isn't found because that needs to come after that. There we go, because this uses ray direction here and that wasn't set till there. So this should work now. This is the last one. Here we go. So down the corridor, does it work? So it works there, but it doesn't work in the walls. That's because I'm timesing that by 100. That needs to be minus because that's the wrong direction. Test, 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 test. There we go. Right. So now that works. Okay. So that's that bit done. That's the hard bit. And now we just need to call that event. What was the event called? Raycast crossed. Self.properties.raycast crossed. Send to call whatever that was. So in our tripwire, you'll see that there's this raycast crossed, and I've already hooked that up with the activation timer script. So now, I mean, it's instant. It's effective, that's for sure. So what I would do is lay my traps. Oh, that's not ideal. Lay my traps down here, and then there you go. So they kind of work. The tricky thing is laying them, but that's okay. I think that's good. I think you have to be daring to be laying traps. You could do a conditional and check whether there's someone that's just laid it. Some of them are exploding twice. We need to stop that from happening to all of the traps. That's in the traps. That's going to be in the obstacle blast script. In here, that doesn't need to be in there. That needs to happen not for each user. But we need to check whether we've blasted. Self.blasted is false. If not self.blasted, then and end there. And then set that to true there. That way, we will only explode once. There. Okay, so that's how to create a few different traps. So what have we done here? We have created some landmines, which work the same way as the collision traps, except now players can use them in the game. So we're really combining some of the obby components with some of the inventory stuff. Then we've also got this tripwire that we created. And what that does is that shows how to combine the obby trap stuff with some inventory stuff and then also write your own trap logic. So here we've written some very specific logic here that raycasts and checks whether something has walked in front of this object. And so that means that we can write whatever code we want to for our trap, or it doesn't have to be a trap. It could be, like I said before, it could be a reward. It could be an in-game event that occurs that you can lay down these things now. Players can lay down these things and get in-game events to happen for other players, whatever those events are. It's the creativity is up to you. All I'm doing is I've just shown you some simple ways that we can combine some of the stuff that we already have to make some really cool things. some additionally cool stuff. So I hope you have found this tutorial helpful. It got quite heavy in the scripting, especially around the tripwire stuff. But let me know if you get stuck, or if you have any feedback for this tutorial, or if any of the maths doesn't really make sense. I know we did some vector maths and all sorts of bits and pieces here, but it's really kind of about breaking down what the steps that we needed to accomplish, and then going and investigating how we might do that, and then doing it. Thanks very much for watching. I look forward to seeing all of your trap games in Crayta.